Hello, everybody. Thank you for joining us today. My name is Manjinder, and I'm excited to welcome you to this session on ethical and environmental AI in assessment. We've got 50 people in the chat right now, which is great to see. A little bit of housekeeping throughout the session. I'll probably be putting up some polls and questions that will come up on the screen. It'd be great if you answer them so that we kind of have a good understanding of where everybody is. I'm sure a few people will come in over the course of the next few minutes. But another thing to talk about is the chat and the questions. So feel free to engage in the chat and talk to your fellow attendees. If you do have any specific questions, I do recommend using the questions tab. The primary reason for this is other people can actually vote on those questions, and that upvoting will allow us to talk about the specific questions that are most popular at hand, and things won't get lost as easily. So with that, let's start in. We're going to start with an interesting point, right? Before we even actually get into the component of ethicalness and sustainability, we're actually going to talk a little bit about how AI actually works, right? So one of the polls I have right now is, one sec. Let me publish this. There we go. Do you know how AI works? Fantastic. So right now, the poll shows this as follows. Around 40% or so say a little and they'd like to know more. 35% say mostly. 20% say yes, and only a few percent say no. Fantastic. So let's get into it. How does AI actually work? Now, I will not be giving a very technical description. That's kind of out of the scope of this talk. But what I will be doing is highlighting the key components that are popular right now to talk about and how things that are key in those processes relate to the ethical and environmental impacts that we're going to be discussing later. So the first thing we're going to talk a little bit about is generative AI. Now, I like to think of generative AI as the world's best auto-predict. If you've used a tool like ChatGPT, Gemini, Claude, all of these use a generative text engine underneath the hood. So how does it actually work? Well, what it does is it tries to predict the best next word. It's effectively an ultra advanced autocomplete. So what I've done here is, taken a large corpus of text, in principle, a massive library, broken up some text into its component parts, which are called tokens. And those tokens then are used to predict what the next model is. Are used to model and predict what the next token is. So a great example of this would be if I was to complete the sentence. I can say something like the cat in the and blank. What fills that sentence, right? And based on your experience of what you've read and what you've lived, you might say hat or box or house. And based on all the examples that we've seen before, we can kind of rank those based on its frequency. And then all we need to do is roll the dice and pick out the random number that corresponds to the list in its order. And then we put that word in. Now, in practice, we use tokens, not words, like we've shown on the screen, but this is effectively how generative systems work. Now, there's another type of artificial intelligence which isn't as popular, but it is just as important. That system is called classification artificial intelligence. Now, it doesn't try to improvise. It sorts information into predefined categories. So if we're talking about, assessment, it could talk about whether or not the student's answer contains particular components or if it references appropriate things. In this example here, I've separated out images of cats and dogs, and it could pick out particular features, maybe the shape of the ears and the eyes. notice similarities and differences. For example, both the images for both animals have 4 legs and a tail. And what's quite interesting is that this is very different because it's a lot more structured. And that structure means that you can often explain how things are working, and it allows for things to be more auditable as well. So why does this actually matter? It matters because how the AI works, whether it's predictive or classification, really affects how fair and transparent and trustworthy these can be used in assessment. Now, when we're talking about assessment specifically, there are lots of AI approaches. Each one of these has a different environmental and ethical impact. I'm just going to go through a few of these now, and we can, of course, discuss these in more detail later. So, the first one I want to talk about is rules-based scoring. The most simple rules-based scoring example that we can talk about is multiple choice, where you have multiple answers, one of which is correct, and we can say if the answer picked is the one that's correct, award the mark. Now, we can become slightly more complicated. We could do some mathematical thinking here. We could say if the answer is 5, or maybe it simplifies down to 5, or if we're doing some words, we could say if the word is house, or any other simple words. Now, the problem with rules-based scoring is that it requires a lot of manual work to be able to create those rules in the first place and set those up. But in principle, it is simply the most simple type of artificial intelligence that we can use. Now we've got a couple of other things. For example, we've got supervised machine learning. This is a system which interacts both with the human and the computer together to be able to create a system where the machine learns how to do the relevant activity, in this case, grading work. It will start with some information, maybe some previous examples, and understand and interpret the content of the particular question and answer to be able to work out what the outcome should be. We have more complex versions of that, for example, like neural networks. These were very popular before generative AI systems came out, and can be used as well. They are a classification system, but they're a little bit more black boxy, so it's hard to understand exactly what's happening underneath the hood. We could use a fine-tuned large language model. So you could take a large language model like ChatGPT and then fine-tune it to do specifically assessment. And then we could even use a fully generative AI system with just a mark scheme. So you don't give it any additional scripts. You just say, here's the mark scheme. How do you actually do the assessment? Now, it's important here, methods 2 through 4 actually require some previous training on human mark scripts. And this will be important when we talk about the ethics associated with each one of these approaches. Now, I just wanted to put a good quote here. Without ethical guardrails, AI risks reproducing real-world biases, discrimination, and fueling divisions and threatening fundamental human right freedoms. And that's from UNESCO. I think that's a very poignant quote because it really can highlight the issues at play here, specifically with the ethics. Now, with that, I've got another question at hand. Have you personally used AI like ChatGPT or other tools in assessment or feedback at your institution? Yes or no? All right, so it looks like we've got a 70-30 split here, where the 70% saying no. So that's quite interesting. Be great to see if people have a discussion as to why they fall on one side or the other. Next is how we're going to talk about the ethical foundations of AI. Right. So in my opinion, there are 4 key components that I would like to consider with respect to ethical foundations. The first is fairness and non-discrimination. So if you use an artificial intelligence system, it should never disadvantage learners based on their race, gender, disability, or background. That's just a straight no-go. The next thing, in my opinion, is to have transparency and explainability. If a student's work is being processed using a technology, or on artificial intelligence, students have the right to understand how those decisions are being made. The third is accountability. There has to be a clear responsibility, which has to be allocated between the people who are creating these systems, the institutions that are using these systems, and the regulators that are monitoring these systems. And fourth is privacy and data governance. We really want to minimize the data collection that's involved in this system. There's no reason to use every bit of information around an individual to be able to run these systems. But on top of that, we need to make sure we have strong security and ensure meaningful consent, like we do currently in other instances. And many systems, unfortunately, don't have that. Now, this can seem like quite a daunting list of things to talk about. But what I'm going to do with respect to artificial intelligence, but what I'm going to do is I'm going to use a useful analogy. And using that analogy, we can talk about these foundations in more of a practical framework. So the analogy I have here is kind of how AI works in practice. So what we're going to do is we're going to imagine we have a new team member. We're going to onboard them into a new process that they've not done before. So there's multiple ways we could do this, but the way that we're going to do this today is we're going to have a list of previous examples of this process. We're going to walk them through it, and then we're going to either give them some examples which they haven't seen before, or maybe we let them out into the real world where we look at how they do things in sort of low risk environments, and we let them try. We teach, and then the really important thing here is we teach them from the mistakes that they make, because inevitably they're not going to get everything right. And then they can, in principle, learn from that. And eventually, when they're ready, when they're most accurate enough and don't make that many mistakes, they're ready to be let out into the wild and be actually do this process. So off the back of that, we can use this to map an analogy on AI. Now, those previous examples that I talked about is the data in these systems. That how we walk them through it is actually the training method. For example, we could say use an SOP, right? And walk them through a detailed process and a standard operating procedure to tell them how to do that work. Or we might just say, this is how it was done before, kind of work it out, see what happens, right? The process of the individual going through that work and understanding is the learning. That's effectively the same. And then lastly is the launch, which is when that person is ready, they go off and actually do that process in the wild. Now, quite quickly, using this analogy, we can see where the particular issues can come about. A significant amount of the ethical issues come directly at the start, which is the data. So when we were talking initially about fairness and non-discrimination, if we gave this individual lots of examples where an outcome disadvantaged a particular group based on their background, based on their race, gender, etc., that would then be taught to that individual. They would effectively replicate the underlying issues that the data had represented, which is why it's so important to control the amount of data that we use and the bias that exists in that data. The next thing is around the privacy and data governance. If we can have a lot of data used in this process, that's going to affect the outcome as well. We need to know where that data is coming from, whether or not it's, consent is provided when the individuals provided the data, and whether or not that data is securely held, because we have a responsibility as educational providers to maintain that security of that data in many data agreements that we have with our students and with our clients. So when we're talking about different models, the understanding of this underlying data is really important. For example, if we use a tool like ChatGPT or a large language model, most of the data that's used in these systems comes from effectively the entirety of the internet. And there is a lot of bias around different groups and backgrounds in that data. which will be propagated into your AI models. Additionally, that data collection, the consent regarding that data collection is a bit confusing and might not be fully transparent. And lastly, on the data governance for those types of systems, quite often, depending on the particular contracts that you might have with those developers, the data that you feed into these systems is now part of the model. You can't separate that out. So you have to make sure that you're using like a read-only version of that model and making sure that that's really important so that there is no contamination between your data and the data that's in that model. If you compare that to, say, a classification system that I was talking about earlier, well, the only data that's provided into a classification system is the data that you put in. So there is a significant degree of control already. And provided that your data, maybe the previous examples that you were using in your assessment, weren't already biased, which of course there might be some issues regarding that, that we always need to be looking after through quality control procedures. But if that is not the case, then that bias will not be propagated. And that provides a significant amount of control. The next thing to really think about here is around transparency and explainability. And the two things here are about the training method and the learning. Now, the generative procedure that I was talking about earlier, the tools that I used, things like ChatGPT and Gemini, those systems, their training method is around breaking up the text, looking at what comes next, and trying to predict what should come after, given a particular amount of text. As you can understand and sort of pretty quickly see, if I was going to train somebody as an individual to do that, you would say that it's very hard to explain how those decisions are being made. And naturally, that is actually the case. So it can cause a lot of issues here. And we can try to interpret those decisions by examining the prompts and looking into their thought processes. But unfortunately, there's a lot of evidence already to show that the introspection of these kind of thought processes aren't very clear. But again, comparing that to, say, a classification model, if you were using a neural network, well, we know how the learning process is being done, but there's often not a lot of explainability. So you can have transparency, but not explainability. You might be using like a supervised machine learning model system instead. And depending on kind of how those models are explained, you might be able to get both transparency and explainability. So that's how specifically we can use this analogy to look at those AI approaches that I talked about earlier to specifically think about the ethical components of AI in assessment. Now, what I want to do here is actually give some examples of where it might have gone right and where it might have gone wrong. The first example here is an example of people using large language models to help grade work. Now, in the two sources that I've listed here, these are scientific papers. What they've done is they took a set of pre-graded exams and they ran through the system to be able to predict what the grade should be based on the content and the question and a grading rubric. Now, what was quite interesting about that is that in one of these results, they found very low replicability with the marking, specifically the distribution. So what I mean by that here is that you can plot your grades on a curve, for example, and they tend to make a particular shape. Sometimes that's a bell curve, sometimes it's skewed toward one side or the other. But when they used large language models, the result was always a bell curve, regardless of the underlying data. So there's quite a significant concern there about replicability. But for me, the thing that really was quite scary is the fact that these systems showed socioeconomic bias. So what I mean by that is they were able to tweak the responses to kind of indicate that the student came from maybe an affluent background or not, and the resulting grade changed as a result, which is quite concerning to me. Now, on the other side of things, and this is kind of where my bias comes through, we've got a system like Grades, which is our system. Now, we use a classification model, and it's based on supervised machine learning. And based on a few different sectors here, we've got training, we've got online learning, and a higher education institution. we've been able to show how to improve the quality of that, the grades and the feedback and the consistency as well, because we've been kind of following these approaches that I'm talking about today. Now, with that, let's move on to the environmental impact. So the question here I have is, do you think your institution has considered the environmental footprint of AI and its uses? Great. So we've got the almost half, well, sorry, around 50, around 40% of people are saying that they're not sure. Around 30% of people are saying yes, and around 30% of people are saying no, which is quite interesting, right? It's quite a point at the top of its matter, particularly right now. And I think people are still thinking about this, which is why we're here to help educate on this particular component. So, in my opinion, there are 4 ways that artificial intelligence affects the environment. The first is energy consumption. So energy consumption is quite important because effectively these models run on computers and electronical components. If the systems that you're using are quite complex, they require a large amount of computation, naturally it requires a lot of electricity. So that there are instances now where we're seeing large tech companies try to build new data centers that are next to power plants because it's easier to build a power plant to get that energy in the future. With that also comes water usage. Now, this one might seem a bit strange, but when you use these electrical components, they require cooling to maintain their ability to work. And the best way to cool these systems most effectively is to use water. So water is effectively piped into these systems. Obviously, it's controlled like in a radiator. It's not just splashed on there. But that's used to cool down the electrical equipment because they produce a lot of heat. The third is emissions. So naturally, the energy consumption that we're talking about here comes with emissions. Now, each system or each plant is going to have its own way of managing where it gets its electricity. They might be getting them from renewable resources, which is fantastic, but they might not be as well. So this is something that's really worth considering when we're talking about the underlying systems that are being used. And then lastly, we have e-waste. And this one's quite interesting. It's not really talked about that much, but a large amount of the technology that we use today for these systems quickly goes out of date. And new instances of chips and systems have to be created to use for those particular artificial intelligence systems. So really, the way I like to think about it is that, AI doesn't really exist in the cloud. It has to be powered by something. So thinking about where it's being used, how much of that power is actually required, allows us to consider the environmental impact of that AI system. So here's an interesting thing. We're going to walk through those different AI systems and talk about how much environmental impact there actually is. Now, the easiest way to think about this, in my opinion, is correlating the consumption of computational power to effectively all of these systems. E-waste is probably one that might have to be considered differently. So how do we do this? Well, to train and deploy a large model often requires a significant amount of computational power. And computational power requires the electricity. That computational power produces heat, which requires the water. and the electricity in the water effectively is the impact that provides the emissions. Now, the component on the emissions that we need to think about is where that particular plant is actually getting their powers. So that's going to require some audit trailing when you're considering different supplies. So with that in mind, we can actually break this down into a pretty simple question. How much computational power does a particular AI approach need? So with a rules-based approach that we had at the start, computational power is very, very low. They use very standard computational logic, if statements, checking really simple mathematical equalities or text-based equalities. These types of systems are so simple that they've been baked into many chips already and could run probably like on a toothbrush. It's really quite simple. Now, naturally, that means that the computational power for that is really low, and therefore the environmental impact of that is also very low. The next one we have is the supervised machine learning. Now, this is where things become kind of interesting. They often require a reasonable amount of computational power. So, for example, some of these systems might not be able to run on like a laptop or a phone, so they do still need a cloud to be able to work. But that might be more to do about scaling and kind of intellectual property protection rather than the specific amount of power, computational power usage. Of course, it does depend on what specific instance of artificial intelligence that you're using in that kind of supervised machine learning system, which is something that you would have to ask your provider. The next we have is neural networks. Now, neural networks can be small and simple, and they can be large and expensive. This is one of these interesting components here, is that talking about the architecture doesn't actually tell you too much about how big it is. An analogy that I could use is, you could say somebody lives in a house. Well, there are lots of small houses and there are lots of massive mansions. And saying somebody lives in a house doesn't say too much. So you actually have to ask, you have to say, how large are these neural networks that we're talking about here? How does that compare against the standard, and where is how much computational power that might actually require as well? The easy way to think about this is neural networks take a significant amount of computational power to train, but they actually are quite energy efficient when running. So even if it is really large, it might still be reasonable in terms of its energy consumption and computational power consumption once it has been trained. And the last two examples were using large language models. So large language models are sort of by definition large, but they require the most computational power because under each section and system of a particular large language model is a large neural network. You've put together large neural networks to create this large language model. And as a result of that, they not only require a significant amount of computational power to train. For example, I believe GPT-4, when it was released, took around a year to train. And it takes a significant amount of electricity to actually run as well. So they naturally are the most environmentally impactful method of artificial intelligence. So now I've given a lot of advice here regarding how to think about the ethical impact and the environmental impact of artificial intelligence. But I'm just a voice on the internet. How do you actually apply these systems and not be overwhelmed by them, right? Because it often feels like there are too many moving parts to ever sort of get anything right. Now, luckily for us, we don't really have to start from scratch because there are already international standards and principles that give us a roadmap. The two that come to mind immediately are ISO, so that's ISO 42001, and the OECD AI principles. So when we talk about ISO, it's really the first global standard that's specifically created for AI management. So if you think of it like the extension of the ISO system that you probably already use, like 27001, but it's tailored for artificial intelligence. So it helps put organizations put their processes in place for the risk management, for the transparency, and the continuous improvement that I was talking about earlier. So as an education provider, it means that you can align your AI governance with a global recognized benchmark rather than having to create your own framework. And another reason this is useful is that existing entities will try to align themselves with this standard as well. And a lot of these issues that I'm talking about can sort of be handled in the short run. The next is the OECD AI principles. So that's another cornerstone, really. So it's been endorsed by 46 countries right now, including the UK and the US. And the big thing here is they emphasize inclusive growth and human-centered values, transparency, robustness, and accountability. Now, remember, it's not like legally binding, but it does shape how like governments or regulators can approach artificial intelligence. So for your reference point as an institution, it's probably easy to make sure that your AI policies are aligned with these so that they're sort of internationally credible. So why does it actually matter, right? So in my opinion, it matters because of two things. One, it shows your students and your staff and the regulators that you're actually serious about responsible artificial intelligence. Now, I think that's not only a necessity, but it also gives you a competitive advantage in this current state. The second thing is it makes your practices interoperable, like in the wider world. So when the new regulations arrive or things change, you're sort of already ahead of the curve. So it allows you, in my opinion, to be agile, right? So it allows you to experiment with different things whilst also being safe. It allows you to research things like explainable AI to maintain that trust and accuracy. In my opinion, it's not about less AI. It's about better AI. And then really, if I were to boil this down into kind of three key takeaways, I think that there are three things to consider, really, or three things to take away. The first is that ethical AI is a continuous process, right? It's not a box ticking exercise. The next is that trust is built through transparency and also fairness and accountability, which I guess wasn't written here. And then lastly, if you are trying to scale AI in assessment, you require foundations, specifically, in my opinion, those ethical and environmental foundations. Because let's face it, the promise of AI in education is real, right? But without the safeguards, we risk undermining the learners that we're actually trying to empower in the first place. So that's it for today's session. I'd like to open the floor up to questions. Please use the questions section. And we can talk a little bit about how these themes sort of resonate with your own experiences in education and assessment. So we've got a question here from Jennifer Fong. When considering skills-based credentials, what are effective AI models that can be used? So there we go. Yeah. So this is an interesting question. I think that it really depends on how you're going to be looking at evidencing those relevant skills. So I think we do live in an instance where many of these models can be used in many different instances. And really the question becomes, how are we going to specifically do that? For example, a lot of these multimodal or generative systems can handle lots of different types of media at the same time. So if you're doing a skills-based assessment, you might be recording them. You might be having an audio transcript. And you might have a presentation, for example, and you could put all of that information to be processed and then used with artificial intelligence to grade that particular work. But if there are different components which are narrow in scope, you might be able to use particular classification systems for that. There's a question here about whether or not we're providing certificates of attendance. If that's something that's important, please reach out to us and we can handle that. So here's a question from Charwood. The question here is, are there ways to access written work or only typed work? This is quite an interesting component here. So when we're talking about handwritten work, there is often a layer that's required for that to be interpreted by a computer. And the layer that it goes through is like optical character recognition. You might have experienced this on your mobile device where you take a picture and you can highlight the text on a menu and it can sometimes do live translation, for example. That sort of technology is also being used on handwriting, and it's proven to be quite effective, which is quite interesting as well. So to have a computer processable information is required as sort of a zeroth level before even thinking about using any type of artificial intelligence. Typed work, of course, is a directly accurate version of that, but I appreciate that not everybody will have, say, access to a computer when they're doing these things. Maybe it's an examination and you're doing something in a hall. But both these systems, basically all systems, if developed appropriately, can handle both written work and typed work. So we got a great question here from Emmanuel. Are there practical steps to be considered before applying AI in assessment? In my opinion, yes. So what I would recommend is one, consider what is required. Is it a formative assessment or a summative assessment? The reason I say this is because the risk outcome is more apparent at that point. A formative assessment in principle has lower risk associated with it. In certain instances, it doesn't, but you're going to have to work that out. The risk, therefore, necessitates the level of accountability and transparency is required in your AI system, specifically in assessment. So what that means is if the risk is moderate or high, you will often require a way to have explainability, because explainability ensures that you have an auditable process that can be introspected if there is a question that arises from a student as to why a particular response was given a particular grade. That's why I tend to lean towards classification systems instead of generative systems, because of the explainability. That's kind of the primary kind of process. After that, there's a question regarding, say, speed, efficacy, accuracy, and all that other stuff. But that's sort of the foundational process before you start thinking about other, maybe more slightly technical requirements. We got a question here from, I believe it's Valeria. Sorry if I'm pronouncing that incorrectly. Could you show an example of how a GCSE maths assessment is marked and the feedback is given? Happily, I can. If you get in touch with our team, we'll show you how our platform works in that specific instance. But I mean, I can quickly talk about it. But effectively, a GCSE maths assessment would be submitted by the student, and then you would annotate on that response using the platform, and that system, that it would be then learned by the platform. And then when a similar response comes up, that would then show feedback as an AI suggestion with a confidence percentage, which effectively would be a degree of that transparency and the explainability that I was talking about earlier. So we've got two questions at once here from Lucas. Would anonymous AI grading be sufficient to remove any discrimination issues? And are there quality comparisons between human assessed grading, who could exert unconscious biases, and the grading of automated grading systems? I think these are two absolutely fantastic questions. The first question is a little bit easy to answer. Generally speaking, if you anonymize the grading, we would hope that it removes a lot of the discrimination issues that are associated with it. It's not a full guarantee. There has been some research that highlights things like handwriting quality or presentation of work has an unconscious bias effect to the result and the outcome. But if we were, say, talking about typed up responses, one would hope that that would be enough. That would hopefully mean that your existing data set is at least reasonably controlled with regards to any discrimination and bias issues before you put it into any other system. And the second question is really, it's quite interesting for me. So a lot of this is regarding inter-rater reliability. So we like to all think that human beings are exactly perfect, and there is no, we're always accurate, even if we're given exact systems. But the data doesn't agree with that. Inter-rater reliability measures if you give two people or more than two people the same set of work, what is the difference in their grading? And generally speaking, people agree, but it's around 80%. Now, the big difference is that the 80%, the 20% might be quite close, right? Or it could be very spread apart. AI systems have this interesting scope, which is they are quite often fully consistent within themselves. The big difference here is that if you use a generative system, it's naturally random because there's a degree of stochasticity required for those models to work, which means quite often if you give a response, it might not be the same response. It might not give the same output for the same response, which is, in my opinion, quite concerning. But the key component here is that you're not comparing against one grader. You should be comparing it against the group of graders and the average, because that will give you a reliable output against the inter-rater reliability. So that's the important thing here, in my opinion. And then you need to be measuring the difference between when it is wrong versus whether or not it's even right, because that's really the shape of the distribution. It's quite a technical question, but it's quite an interesting one. To give you some anecdotal evidence with kind of our platform, for example, we have quite a high degree of overlap with the multiple raters at the same time. So yeah. We've got an interesting question here regarding, from Ravi Patel. Many universities jumped right into developing their own AI systems and ecosystems available to faculties and students and staff. Others are focusing on what is available through the market by different providers to meet their needs. What's your perspective on these approaches from an ethical perspective? So this is a really important point. I think it has been so easy to integrate and use these systems, either from a standalone point of view or integrated into these systems. We might not have fully considered the ethical impacts of doing this when and I say we, I mean society, was doing this. So a great example of this is I've heard about teachers using tools like ChatGPT to help grade their work. The problem is the free version of ChatGPT and even the pro version, because you don't have an enterprise license, takes the data that you're providing. So you're actually using the student's work, which is their intellectual property, and you're feeding it into these systems which now they have access to it to train those models. And that is a significant issue. And of course, there's the underlying biases that I talked about using large language models, etc., and all that sort of stuff. Now, look, the genie's out of the bottle. We can't undo that. But what we can do is we can be reasonable going forward. And we can be introspective to see that when we have used these instances ourselves, are we doing the right thing, or do we need to stop and think of something different? And that's why it's really important to be talking about and educating on these topics. Okay, so if there aren't any more questions, I'm going to call it here. It's been absolutely wonderful to have the engagement from the group here, and I hope you found this useful. We will be sending out a recording of this, and probably a little bit of a write-up and maybe a few more bits of information. There is another question just pointed up, and I'll answer that in a minute. But yeah, I just wanted to thank everybody for coming. So we've got a question from Vicky Brown here. Picking up on your ethical point, how do we square with students using artificial intelligence to mark and grade student work when we're imposing restrictions on whether they can use AI in submitting on certain assessments? I think this is a really reasonable point to be discussing. And I think the point here is around being transparent, right? The first part is the reason we are considering artificial intelligence, or rather imposing restrictions on students using artificial intelligence, is around making sure that the output of their work or something is reasonably qualified for the certification that is often coming out. So what I mean by that is institutions are being held to a particular standard to ensure that the students know what they're actually doing. And the big thing here is, if students are just using a simple artificial intelligence system, copying and pasting the answer in, they aren't going to be appropriately qualified. In different cases, this can be quite dangerous, right? You can think of this in a medical setting or construction, for example. If they don't know what they're talking about, then this could be quite dangerous. On the other side of things, around using artificial intelligence to mark and grade work, this is really a question about process. And the second part is, if you're transparent about the fact that you built a process that has a human in the loop and is really just about creating efficiencies, it's not about replacing the judgment, then that students are quite receptive to that component. And I think there is always a good differentiation that's required with regards to whether or not it's generative or classification, because the students using artificial intelligence right now are using generative systems. So if you end up using a classification system, it's completely different. Like, in my opinion, yes, I appreciate that both artificial intelligence, but that's like saying technology. These systems are so vastly different that they really don't necessarily belong in the same bucket. We've got a question here from Amy. What are my thoughts on using these AI assessment tools in competition setting, replacing or enhancing judgment and critique? This is really quite interesting. I think I have a particular way of thinking about this personally. I think that all systems should be seeded by critique that is appropriately created from that judge, right? From that rater, from the grader. And the reason that I say this is that there's a significant amount of pedagogical insight that goes into creating a rubric or even grading any work that is relevant to the context of that particular piece of assessment. After that, after enough has been sort of stated, then it becomes a question of iterating and repeating that judgment, where that particular work was done in its highest quality setting, right? That's really where the efficiencies come in. In my opinion, replacing it right from the start doesn't make a lot of sense. especially because there's so much nuance involved. It just doesn't make a lot of sense to me. I personally think that artificial intelligence should be used to enhance those processes, not really replace them. Okay, so thank you very much again for attending. It's been absolutely fantastic answering these questions, and they have been really, really good questions. So if you have any more, you can always get in touch via the website. We'll be sending across the recording, etc. And yeah, we look forward to seeing you in the future. Take care, everyone.